This video is on empirical and molecular formulas, some general background as well as how to calculate both of them. So first, empirical. Your empirical formula will be the simplest whole number ratio. It's the reduced version. It might not necessarily be true, but it's the simplest, most simplified version. Your molecular formula is the actual formula for your compound. So instead of being the simple version, it is what it actually is. For example, if we have something that looks like this, my nitrogen is being represented as my colored in circles, and my oxygen are my open circles. If I wanted the molecular formula for this, currently abbreviated as MS, molecular formula, it would be how many I actually have. So for example, my nitrogen, I actually have 1, 2, so I'm going to say N2. Then I have oxygen, and I have 1, 2, 3, 4 oxygens. That is the number that I actually have. It's my molecular formula. My empirical formula, abbreviated as EF, is my reduced form, my simplified form of this. So for example, I have 2 N's and 4 oxygens. Well, both of these numbers are divisible by 2. 2 is divisible by 2 and 4 is divisible by 2. So I can reduce both of these so that it becomes, instead of N2, it'd be just N1. And instead of O4, it would become O2. I basically halved everything until it was a smaller whole number. I can't go any smaller than that because otherwise then I'm not a whole number anymore. That is an empirical formula, a simplified version. Here's another example. So if I have C3H6, my simplified version of that would be to reduce the 3 and the 6. Well, I can reduce both of those by 3. So 3 divided by 3 gives me just C1. 6 divided by 3 gives me H2. So I'd have CH2. Those are some conceptual examples for empirical and molecular formulas. Now, if I want to figure out how to calculate empirical formulas, let's start with empirical. These are the steps I'm going to follow, and I'm going to give you the steps all at once first, and then we'll break them down and see the example. So your first step, convert whatever you're given into moles. It could either give you grams, in which case we just can take our grams into moles using our fence posts, or it might give you a percent of your substance. Over here with grams would be something like your sample contains 6.5 grams of carbon and 8.9 grams of hydrogen. We would convert both of those into moles. If it gives you a percentage, it might say something like 75% is carbon and 25% is hydrogen. In this case, your percent number, so for example, 75% of carbon, that is the exact same as your number of grams. So if I have 75%, it means I have 75 grams of carbon. It is the exact same number. We need grams in order to go into moles. Your second step, once we have both of our units into moles, then we divide by our smallest number of moles to get a whole ratio. This makes more sense seeing an example, so I know it might sound confusing now, but we'll see this again with an example. Now, we need that to be a whole number. If we don't get a whole number after we divide, then we have to multiply by either 2, or let's try 3, or let's try 4, or 5, or 6, or whatever, in order to get it to a whole number. Now, what am I calling a whole number? What's close enough to round? If you have something like 1.8, that is close enough. We can round that to 2. If we have something like 2.2, that's close enough that we can round that down to be 2. But if you divide, and you divide your moles, and you get something that's like 1.5, that's halfway between 1 and 2. We can't round that. So that's when I'm going to multiply it by 2, or by 3, or by 4, or whatever I need to in order to get it to be a whole number. 1.5 times 2 gets me my whole number of 3. We might see an example like this. The hardest you'll get is to multiply it by 2. You probably won't see a by 3 or a by 4. But in the back of your head, if you ever do go into higher chemistry and you do need to have a higher number, just try any integer that works. Your third step, we're going to use the whole numbers we get from our step 2 up here, and then we're going to use that to write the empirical formula. Those are the process, that's the steps we're going to follow. Let's now go ahead and break those steps down. And I'm going to leave these kind of nearby so we can reference them. So, our example, a sample compound is found to contain 65.5 grams of carbon, 5.5 grams of hydrogen, and 29.0 grams of oxygen. Determine the empirical formula from the compound. Well, our first step is to take whatever we're given and we're going to convert that into moles. So, I'm going to take my 65.5 grams of carbon, this first amount there. My first element for carbon, I need to convert that into moles. If you're having trouble with conversions, check the video I've already made for conversions. I've got 3 of them. This is for carbon, so I'm using the molar mass for carbon. Molar mass of carbon is 12.01. I'm going to put that on the bottom with grams. When I plug this into my calculator, I take my 65.5 divided by 12.01. I get 5.45 moles of carbon. Great. We need to do that for everything. So then I'm going to take my 5.5 grams of hydrogen. 5.5 grams of hydrogen and convert that into moles. Grams on the bottom, moles on top. 1 mole is equal to 1.008 grams of hydrogen. I'm rounding the molar mass. To get moles, I take 5.5 divided by 1.008, and I get 5.45 moles of hydrogen. Then I have this 29, sorry, I keep moving my paper around, which is probably making you seasick. I have this 29.0 grams of oxygen. I need to convert that into moles. 29.0 grams oxygen, grams of oxygen on the bottom, moles of oxygen on the top. 1 oxygen's about 16. You can also use 15.99. So I'm going to take my 29.0 divided by my 16. It gives me 1.8125 moles of oxygen. And I gave a lot more digits there, sorry. That is the first step for my empirical formula. Convert what you're given into moles. Then, our second step, and only once we have moles, then we divide by the smallest number of moles to get a whole number ratio. So, if I compare all of these number of moles, this bottom one is my smallest. So, I am going to divide all of these by my smallest. Similar to when we did relative mass, everything was divided by the smallest. Same thing here. I'm going to divide everything by this smallest number, 1.8125 moles. This is divided by 1.8125 moles, and this is divided by 1.8125 moles. Now, 1.8125 divided by 1.8125, I can do that in my head. That's just 1. I have 1 oxygen. here, 5.45 divided by 1.8125 gives me 3.0068. Well, that's pretty close to a whole number. That says 3. That is in reference to my hydrogens. So I have 3 hydrogens. Well, carbon was the exact same number of moles as hydrogen, so when I divide them, it's going to be the same number. I'm going to get 3 carbons. Notice that all of these were whole numbers. We didn't have to worry about multiplying by another integer, another number, in order to get it to a whole number. Good. My third step is I use the whole numbers from step 2 and I write my empirical formula. So I have 3 carbons, so I'm going to write C3. I have 3 hydrogens, so I'm going to write H3. And I have 1 oxygen, so I'm going to write an oxygen. This is your empirical formula. It's a formula. You have to give me all of the letters and how many we have for those letters. If you just gave me 3, 3, 1, that's not the correct answer. I need it written as a formula. My lights went out. Sorry, I'm going to pause this and make this my first video. So that's empirical formula.